Okay, so simplify. So if we've got 4x times 4x, the first thing we do is 4 times 4, which we know is 16. But we also have x times x, which we know is x squared. So don't forget, you've got to multiply everything together. You can't just multiply 4x by 4. That would give you 16x. But 4x multiplied by 4x gives you 16x squared. X times x is x squared. Then we've got a long string of additions with different factors. The first thing we're looking for is, where do I have x squareds? Well, I have an x squared here, a 4, and I have 1, and I have minus 5. 5x squareds minus 5x squared, then back to 0. And do I have any other x squareds? Have I written the question up wrong?
No.
Yes, yes I have. It should be 2x squared there. So I've got 0x squares there, but I've also got an x squared term here. So I'd end up as 2x squared. Now I've finished all my x squared terms. I can cross them out to make sure I don't try and add them or subtract them again. Now I'm looking at my x terms. I have 3x here minus 4x. 3x minus 4x would give me minus x. So that would be the most simplified term of that expression. Here, I've asked you to simplify, so I need you to make a change, and you can't just say there's nothing to do. You could simplify this by taking out the x outside the front of a bracket, and then behind the bracket you would get x squared plus 9. So you could simplify this term by taking the x out the front. If I expanded these brackets, I'd get x cubed plus 9x. 3 cubed plus 9 plus 3, well, I could use the same principle that I used up here. I would get 3 outside the front multiplied by 3 squared plus 9. 9 is also 3 squared, so I could get 3 multiplied by 3 squared plus 3 squared, which is 3 multiplied by 9 plus 9, which is 18, which is the same as, it's easier to do your 9 times tables than your 18 times tables. Double this one and half that one. 6 9s are 54. So this one you had to complete all the way through to 54 in some way, and it doesn't matter how you did it, as long as you got 54. Here we have 3 terms multiplied by each other. This is a 1 in front, so we get 1 times 3 times 4, which is 12. We have an x times an x times an x, so that would be x cubed. 12x cubed. Here we have a 2 times a 3, which would give us a 6. And then we have an x times a y times a z, which we would write as x, y, z. These terms are all multiplied together. So first we're looking for numbers, and then we just put the terms after each other in alphabetical order. Here we have addition, so we're looking at x terms first. Here we have 3x, and here we have 2x, so that would give us 5 lots of x. And then we have minus 2y minus another y. Minus 2 minus 1 is going to give us minus 3, so we have minus 3 lots of y. There was a bracket there, wasn't there, in the question?
Yeah.
I think? Yeah. So let's take away the brackets first. 3x plus 2 doesn't change. There's just like a plus 1 multiplied by in front of that. So there's no change here. But here we have a minus in front of the brackets. I've told you to be careful there. This one turns into minus 4x, of course. But often you forget to think of minus 1 times plus 3, giving you minus 3. Now we've expanded the brackets. Now we can do our simple addition and subtraction. 3x minus 4x gives minus x, plus 2 minus 3 gives minus 1. Minus x minus 1 is that one simplified out. This one we can see very easily that all of the numbers here are a factor of 7. So the simplest thing to do here would be to divide each of these expressions by 7. And you're allowed to do whatever you want as long as you do the same thing to every figure. So you divide each of them by 7. 7y divided by 7 would give you y. Minus stays the same. 14 divided by 7 would give you 2. divide it all by 21 divided by 7 would give you 3. So you're looking for common factors there. And you can either leave it like this, y minus 2 over 3, or you could say y over 3 minus 2/3. Because the question is in fractions, I'd really like you to leave your answers in fractions and not write, it can be tempting to write 0.3 recurring y minus 0.6 recurring without 1. Something like that. But if you've got it in fractions, it's easy to manipulate later. So keep it in fractions, especially when the question was asked in fractions. Then we have a bit of FOIL here, where we're trying to show our skills in multiplying out with brackets. Where the first thing we do is multiply the first two terms together. 2x times 3x would give me 6x squared. That was my first two. Then I do my outside two. 2x times 3. 2x times 3 would give me plus 6x. Then I do my inside 2. 2 times 3x, that would also give me plus 6x. And then I finish off with my last two. Plus 2 times plus 3. 2 3s are 6. So now I'm not quite ready because I have an x term here and an x term here. So to finish off this type of expansion with brackets, we always have to simplify. This would give us 6x squared plus 12 lots of x plus 6. And that's your final answer. Then we have one here, but with some negative numbers as well, just to make sure that you remember how to multiply positive and negative numbers. 2x times 3x is 6x squared again. 2x times minus 2 will give us minus 4x. Plus 4 times 3x will give us 4 3s are 12, 12x. And then we finish off with plus 4 times minus 2 giving us minus 8. So we have, simplify again, 6x squared. That's our only x squared term. 12x minus 4x will give us 8 plus 8x. And minus 8 again. And that's how we would leave that one. Then there was another couple. Make a bit of space here. We have x squared equals 900. So we know that x must equal the square root of 900. But we know that the square root of 900 can be written as the term of square root of 9 times square root of 100, using our surd theory. We know that the square root of 9 is plus or minus 3. And we know that the square root of 100 is 10, plus or minus 10. So we have 3 tens of 30. So we know that the square root of 900 could be plus or minus 30. And it's important to remember whenever you have a square root, you have two solutions. Because if I was to multiply 30 times 30, I would of course get 900. But if I was to multiply minus 30 times minus 30, two negatives multiplied together give you a positive. It would also give me 900. So every square root, if it's just a sum, always has two solutions, plus or minus. If they've told you to calculate the sides of a square, and they've told you that the area is 49, then you can't end up with a square that's minus 7 centimeters in dimension. So in that case, you'd end up with a positive area, a positive side. So you don't need to worry about it when you're doing geometry, but you do in all of this type of one. So if you've only got plus 30 there as the answer, you only get half the marks because there was two answers to that question. Then we have another similar one. X plus 5 multiplied by x minus 5 equals 0. And there's two ways of thinking of this. You can look at this, it's already set up really nicely with your brackets. So you can actually say x plus 5, if this one equals 0, then x plus 5 would equal 0. This one, x minus 5, also equals 0. So you can set each of these up as a separate equation because these two are multiplied by one another. So it gives you the answer directly. You can see when you rearrange this and move that 5 over to the other side, you get x equals minus 5 as one of your solutions. And here, if you move the 5 over to the other side here, it becomes positive. You get x equals 5 as your solution. That looks a bit new for you. We haven't looked at them in that way. But it's easy. It's really easy when you get two factors multiplied by each other. If I was to write x plus 2 multiplied by x minus 3 equals 0, the answer to that equation is x equals minus 2. This one just changes the sign, giving you the answer. And here, x equals plus 3. So when they're set up like this form, with two brackets multiplied by each other equals 0, the solution falls out. Let me prove it to you in a way that you're more familiar with. Let's expand these brackets. If we were to expand these brackets, we'd get x squared, first two, minus 5x, outside 2, plus 5x, inside 2, minus 25, equals 0. Because we've told you that that expression equals 0. 5x minus 5x disappeared. So you get that this one simplifies to x squared minus 25 equals 0. Move the 25 to the other side, you know that x squared equals 25. So x must be the square root of 25, which you know is plus or minus 5. So this is the proof that this method works. And it's a useful method. If they do put it at any time in these brackets multiplied by each other, you can just take each of those expressions by themselves. Oh, so x plus 5 must equal 0, and x minus 5 must equal 0, and then solve. This method makes sure you don't forget the plus and minus, because they all fall out naturally here. So it's very useful. Okay, so that was those first easy questions.